This is a short video demonstrating GURU, an interactive learning platform for cyber-physical education, and specifically GURU CPS, which is focused on OT security or operational technology security, also known as cyber-physical security. This project has been implemented at the iTrust Center for Research in Cybersecurity, which is hosted at the Singapore University of Technology and Design, and the list of contributors to this project are listed on the screen. Instead, they're actively doing exercises and listening to lectures one after the other. So every 2-3 minutes of theory in GURU is followed by an exercise which the students actively take part in, and then they can be monitored and evaluated based on that. And their learning style can be adapted based on that. Then GURU also supports peer learning. GURU can be used to design engaging cyber exercises as well as regular exercises for different course topics. GURU can be used to monitor any student or the entire classroom. So the instructor has the facilities available to them for monitoring any one student screen or the entire classroom screen. GURU can be used to engage teaching assistants to help out the teacher in the conduct of the course. The GURU method and the platform can be used to train the trainer as well. So if GURU has to be extended to a wide audience, the train the trainer model is also included with it. And one feature which we haven't implemented, but which can be integrated in the future, is that GURU can be enhanced with emerging tech such as augmented reality and virtual reality. We do use GURU with a digital twin, which I'll cover in this particular section. So for cyber physical systems in particular, GURU offers a customizable learning management platform, supports live firing cyber exercises, which can be red teaming exercises or blue teaming exercises, where there's attackers and defenders trying to achieve certain objectives for security of a system. GURU has a classroom orchestrator software, which can be used to monitor the entire classroom. It can be used to offer multimodal courses through the media of slides, labs, and discussion forums. GURU is deeply integrated with the digital twin of a realistic water treatment plant in iTrust known as SWaT, or the Secure Water Treatment Plant. And through that, we can learn both IT, which is information technology, and OT, which is operational technology, which includes sensors, actuators, remote input-output units, PLCs, such as programmable logic controllers, and many other devices. So GURU, for this purpose, has been integrated with IT and OT anomaly detectors as well. And for attackers or instructors wishing to launch attacks on these digital twins, the attack launcher for SWaT has been integrated with GURU for both OT as well as IT attacks. One thing which we are working on currently is to have reconfigurable virtualized classrooms on the cloud using a solution such as Ansible. So why do we need GURU? We need GURU because the role of cyber-physical learning is clear in this work from anywhere world, where organizations have their employees spread out across multiple locations, or students are spread out across multiple locations and groups of students can be in one location. So while the role of cyber-physical learning is clear, it is definitely not enough. It's definitely not enough in the field of cyber-physical systems, which GURU focuses on. This is because GURU works in the CPS domain, in which we have to learn both cyber attacks as well as physical attacks and the interaction between them. So when the cyber-physical domain is introduced, the list of protocols, the list of components multiplies manyfold. So the attack surface that we have to study for a system increases with the increase in cyber-physical attacks and physical cyber attacks. I'll describe what these are. First, let's understand different domains where attacks take place. And cyber-physical warfare is becoming more and more common in all these areas that need to be defended: sea, space, air, land, the human element, which can be affected by culture, as well as the cyber element, which governs all these different infrastructures. And because our systems are no longer just cyber or just physical, we need to study them as a whole. For example, a water treatment system has a bunch of sensors and actuators, control devices, and utility devices, which are listed here. The same goes for pacemakers, automobiles like cars, as well as our smartphones and many other devices that surround us today. Real world cyber physical attacks that have taken place on critical infrastructures all over the world are listed here. For example, the Ukraine attack, which was a spear phishing attack on a power plant, in which the origin was an HMI malware, but the cyber impact was loss of availability of the systems, but the physical impact of it was blackouts in an entire section of the city. Similarly, different attacks such as the Florida water plant attack and the other attacks listed here are all cyber physical attacks. The difference between cyber attacks and physical attacks is that in cyber attacks, origin impact is both in the cyber domain and is restricted to the digital cyber domain. When it's in the physical attack, the origin is the physical world. The impact is also in the physical world. For example, drilling a hole in a tank. In a cyber physical attack on a cyber physical system, the origin can be in the cyber domain, but the impact is felt in the physical domain. For example, command injection. Command injection on an actuator, such as a pump, which can be turned on and off, resulting in a pump potentially exploding. The reason for developing Guru came from designing different learning-focused cyber exercises since the last 6-7 years almost. And these are listed on this particular slide. And here is one example of the digital twin of SWaT being used by 24 different NATO countries in one of the biggest cyber exercises of the world, that is Locked Shields. And the SWaT digital twin is modeled after an actual physical testbed of the secure water treatment testbed in iTrust, which looks something like this. It has a list of actuators and sensors. So we see a sensor here, such as a flow meter. We see an actuator here, such as a motorized valve, which can be opened and closed using digital commands. And the HMI or the human machine interface looks something like this. We redesigned it for the digital twin by making it look something like this. So it resembles the exact same as the HMI used for the actual water testbed. And the digital twin is modeled exactly after the behavior of SWaT. So it has all the 4 stages. In the future, our goal is to integrate all the different testbeds that we have at iTrust and create a system of twins which can be used for training. Some features and screenshots of how Guru works are listed here. The customized OpenEDX setup, which is used as the learning management platform, a digital twin of SWaT, which is shown here, an attack desk, which can be used for attacking and launching different kinds of OT and IT attacks on the water treatment system through the digital plant, full visibility into the class as seen here. So an instructor can see what the students are doing. There's chat available for students and teachers for instant feedback if the students are remotely located. There's the ability to record learning sessions for each of the students or specific students. There's the ability to launch specific learning scenarios. So for example, different websites which are pre-configured can be launched on all these student screens or on specific student screens. Also, the learning management platform has objective-oriented courses. For example, there can be a specific course that we have designed for attack and defense of industrial control systems. There can be another course for process operation and troubleshooting for plant engineers. And for operators or engineers wanting to get an introduction to Python, we can have another course. So the platform allows us to create many such courses with infinite flexibility. There's a synchronized gradebook available for all the different students in the course. There's a discussion forum available in the course for students who are registered in a long-running course. There's a task creator, which enables the instructors to design many different multimodal problem statements as well as exercises. And all of these different applications that I showed you can be launched arbitrarily on any of the student screens or on all student screens, which can be used to kill processes on the different systems, launch the digital twin, launch attack detectors, launch attack launchers, Wireshark, and any other tool. So this can be configured by the instructor and the team of teaching assistants as custom applications that can be launched. There's the ability to transfer files, to take screenshots of messages, to power on, reboot, log in, and log off, and broadcast a text message on all the screens. The network anomaly detection in GURU looks something like this. So we can study how an attack flows across different IP addresses in the network. There's the ability to have peer learning support where students can talk to each other. And if the students are not accessing the virtual machines provided by the GURU team, the instructor can also log their screens so that the students can resume next time whenever they are back to learning. Then the ability to share specific screens, like the instructor screen to every student or the student screen to all the other students and the instructor. So the screen sharing facility is quite flexible in GURU. In this very short video, I'll show how GURU has been used in a live classroom demonstration to teach a bunch of school kids OT security. So in this particular class, you see the instructor monitoring different students from student 0 to student 5. And we can monitor the classroom and configure it as mentioned here. And different students can learn at their own pace, and the instructor can see what each student is focused on while the lecture is being conducted. Conversely, an instructor can only broadcast their screen as well on all the student screens. So there's infinite flexibility in this regard. So once the instructor has been through some slides and some theory, the instructor can then launch a specific application like the digital twin shown here. Let's try to take a closer look at that. So once the start application section is selected, then an application is launched on all the student screens. Yeah, so the quick launch tool for GURU launches the twin on all the student screens. Then as GURU launches on all the student screens, the local HMI is also launched. And gradually we see that every student has a local version of the twin, the digital twin of SWaT, running on their own VMs. So each student has their GURU or talk to the team. Feel free to scan this QR code and we'll be in touch with you.
So now the objective is to supply sufficient water to the next stage, but we need to understand how the system works and what are the OT components. Okay, so we look at the components: the water tank, okay, the water pumps, the pipes, the valves, the level of water, and the power on-off, as well as the water. So these are all the components in stage 1, the secure water treatment system. Okay. So usually, traditionally, water plants have the systems are old, and usually we update. What happens if you want to control a plant or ensuring the plant is running safely, right? So how can we reduce manual labor here, right? So we need to understand what are the active components and what are the passive components, right? So active components involve water pump, valves, level of water, the on-off of the individual components, and of course the passive components are water tank, water, pipes, right? Okay, so this is the SCADA that we see back in secure water treatment plant. Okay, so now I will launch the cyber twin for all of you. Okay, please select remote host for me, then click done. Okay. So now I will launch the HMI.
We've showcased how the GURU platform enables live classroom demonstrations, bringing OT security concepts to life in an interactive and engaging way. I hope this video has provided valuable insights into OT security and how the GURU platform can enhance teaching experiences. We encourage you to delve deeper into the world of OT security and leverage the GURU platform for impactful learning. For more information, please contact us. Thank you for watching.